Okay, so in this session, we are going to see how to connect to basic Excel and how to visualize the data and
Okay.
what happens when we connect to data and what are the by default things that Tableau does the data, like segregating the dimensions and measures and identifying the data types of the fields that are there in the data. So, and what are auto-generated fields in Tableau. And today we are going to discuss about what is live and extract connection and how to save the Tableau file as well. So now let's just create a table like this. So a table which has this information of region and that region belongs to which country and all. So with this information, we are going to create one data. Now let's just take this data. So there are multiple ways you can keep the data to the Tableau. So I just copied that. So you can directly paste it in the Tableau itself. So I'll go to a new sheet. So we can directly paste it in the Tableau, or we can paste that in an Excel file and we can connect that to the dashboard. So I'm just pasting it here. So this is my data. Okay, this is taking some time. Yeah. So the thing is, we can copy the clipboard. So whenever you copy something from any PDF or from any of the Excel file, or if you are picking it from any PPT, so you can directly do a Control C, Control V, and it will be pasted as a clipboard. Tableau could not connect to the data source. Okay, I will show you that in the next session. I think there is some issue while connecting clipboard. So now let's connect to Excel file for now. Okay, I'm just saving this file. Okay, so I'll save this file. Section 3. And I'll go here and select Microsoft Excel. And I'll select this session 3. So now I have, there are 2 sheets in the Excel file. So Tableau will not automatically pick the sheets. So we need to manually drag and drop the sheets into the data pane. Okay, so now we need to select so which one we want to show into the dashboard. So earlier we had so in yesterday's session we had only one sheet. So Tableau automatically took one sheet into the data pane here. So now we need to put this sheet too. Yeah. So this is how we can pull the data. Yeah. So by seeing this data, we can identify that this is an hierarchical data. Let's say region, under that countries will be there. Like in APAC region, there are 3 countries, and in India region, there are 3 countries. So likewise for North America. So what happens when we connect this data to the Tableau? So Tableau automatically identifies country names. So whenever we give country names or districts or any city names, so Tableau automatically identifies that it is a country name or city name or the place. Tableau automatically identifies the location names. So what happens is it will give a globe symbol, so it geographical symbol, and we can create maps using this particular field. Whichever is the country field or city field or district field or state field. So we can create maps by using this type of fields. And the ones which has globe symbol is useful to create map charts or symbol charts. And the Tableau also segregates dimensions and measures. So if you see here, so country and region are under the dimensions. And if you see the sales is a measure, which is a measurable, so that goes under measures. So now let's just see it in the live. So let's go to the dashboard. Okay. You see here we have country region in one place. So these are dimensions and sales is a measure. So it got segregated and we have a geographical symbol here. So when I put this country over here, so I have this country names. So if I want to see geolocation of that particular country, so there is a map over here. If I click on that, it will show the locations. Let's say India. It will point to that particular location, and you can show. So what happens when we have a location, or let's say if we have city names in the field, what happens when we connect to the Tableau? When we connect that field to the Tableau?
So if you have the fields and if we connect to the Tableau, it shows on here in the columns or rows, right?
No, that will become a geolocation like this. Let's say I have a field like city, so that becomes a column which has a geolocation. So when you put that field to the rows or columns, we can create a map chart like this.
Yes.
And you can show the sales or profit or anything on top of that particular location. So that user will automatically identify in which location it has the more number of sales or more number of profit. So that we can identify. Tableau will automatically generate new fields. So if you see in the data, we have only country, region, and sales. So if you see, I have pulled only these 3 columns. But apart from these three columns, I also have extra columns, which is measure names, latitude, longitude, and number of records, measure values. So these are the by default Tableau generated fields where we can use it for our calculations. So latitude and longitude is something which comes only when you have some geolocation, like country, city, state. Whenever you have this type of field, then only you will get these two latitude and longitude. So this map is getting generated only because of these two fields, latitude and longitude. So whenever we are keeping this country and selecting map, so latitude and longitude will be automatically kept in these columns and rows, and based on that only we are able to point that particular location.
Okay.
And number of records, to see how many number of records that are there and for the entire data or for each and every field, we can see that. So let's just it is named as sheet to count over here. So let's just see. So there are 9 records. So let's go to the data. And if you see, we have 9 records. So see the number of records. And if you want to see how many records that are there for each and every region. For each region, we have 3 records.
Yeah.
So, yeah.
Sales.
So if we go to data, so if you see for APAC, we have 3, for EMEA 3, North America 3.
Mm-hmm.
Okay, so now let's talk about the auto-generated fields in Tableau. So measure names and measure values. So these two are very important while creating multi type of charts. Let's say you are creating dual axis charts or any type of dual charts. We can use these particular measure names or measure values. So now let's see what does this measure names and measure values contains. So measure names, in the name, in the title itself, which is there that it contains the names. So it contains the header names of all the fields in measure. So let's say you have sales, you have profit, you have discount. So you will have a lot of measures in your data. So in that data, so you will be able to have all the names of these particular measures in one particular place. So that is what is measure names. So in case of our data, so let's see. So in case of our data, we have only one sales, I mean one measure, which is sales. So if we go here and put measure names, measure names. So we can see sales and count of sheet 2 is also a measure. So this is a by default one, which Tableau will automatically create. So we need to use this combination, measure names and measure values. It's a combination. You can't use one at a time. So let's say if I am using only measure names, so I don't see anything. It won't show anything. So otherwise, if you are using measure values, it will show the combination of these two measures. So that, but there is no way you can sum up these two. Let's say sales is some different measure and the count of records. So let's go here. Okay, 3,400. So it is showing both of them in one place. But the thing is, we need to show both of them differently. So what we need to do, we need to keep measure names. So measure names, if I keep it, sales we have 3,400 and the number of records are 9. So to segregate that particular thing, we need to have measure names and measure values. Now let's see. So this particular field, measure names, is used to create advanced level of charts in Tableau. And measure names can be filtered or to restrict the number of measures or KPIs to be shown in the chart. So
Can you tell me about this KPI, key performance indicator? What is that?
yeah, KPI, key performance indicator. So key performance is indicator is nothing but which defines the performance of your organization, or based on this particular KPI only, we will get to know how the business is performing. So whether if there are higher the better KPIs and lower the better KPIs. So when I say higher the better KPIs, let's say sales,
Oh,
profit.
what is that? Higher, better KPIs, right? You're talking about higher, better KPIs and lower, better KPIs.
Yeah. So let's say you want your sales to increase and you want more profits. Let's say if you
Okay.
are selling something, you expect that to get more profit. Let's say you buy some, sorry, you're selling some iPhone, let's say for 1 lakh,
Mm-hmm.
and you are getting 20K profit. Or if you want more profit, like 25K, 30K. So these are higher the better KPIs. Like profit is a, you want more profit, right? So in such cases, so profit is called as a higher the better KPI. So if you are getting high profits, that means it's good.
Okay.
And there are some lower the better KPIs. Let's say cost. So when I say cost, let's say we have a product and we sold that product to the customer. So for some 1 lakh, okay, and we got a profit of 20K, and cost for that product. What I mean by cost is, let's say, after selling the product, we will give warranty to that product, right? And while manufacturing some products, we uh, throw some of the scrap. Let's say if you are manufacturing some any, let's say iPhone only, so you will have some scrap for that particular material. Like, yeah, you are using some material to create that iPhone, and there will be some scrap which you will throw out. So those are the things which are going to be your cost. So that will become, so you want your cost to be less. So let's say if a user comes to you and complains about your iPhone, and you want to give, let's say you have to replace some part of that particular iPhone. So you will be putting some cost on that. Like out of your profit, you might put some 5K or 10K. Okay. If you are putting more cost on the product, that means it's a loss for you. So that will become your lower the better KPI. So this has to be low. Like you should not put any more cost on that product. So you are getting 20K and you can't put more than 20K like that. Is it clear? No.
Yeah, continue.
Okay, so this in any organization this will be there, like higher the better KPI and lower the better KPI. So and while creating the charts, what we do is, let's say if a sales process 500K, so we show that in a green color. So it's a higher the better KPI. Let's say greater than 500K, for higher the better KPIs, we show it like that. And less than 500K, we show it in a red color. Like we should get sales of 500K, more than 500K. These are like targets. In case of lower the better KPIs, what we do, it will be the opposite. The target should be, let's say, if you are taking a cost as an example, greater than 10K, which should be in red color. Why? Because this KPI should be lesser the better or lower the better in green color. Okay, so this is the kind of representation that we do in Tableau, and not only in Tableau, in reporting standards, what we do is there are three colors. Let's say red, green, and orange. These are the three colors we should not use without necessary usage. Let's say in case of this particular condition. So I'm saying if it is more than 500K, that should be in green color, and if it is less than 500K, it should be in red color. But you can't use it for normal simple reasons. Let's say I have created a bubble chart here. Bubble chart. Okay. So I have this particular chart. Here I am using some colors which represents segment: consumer, corporate, home office. Here the home office is in red color. So I should not use red color for home office. Why? Because I'm not representing that home office is bad in something. So I'm just representing some color for each and every segment. I'm not saying home office is bad. Okay, so if you are saying something, let's say if you want to show something or highlight something as performing bad or performing good, then only we use these three colors. Orange is for moderate. Okay, is your question clear or any doubts?
Yeah, no.
And we use measure names for multiple to create multiple line chart or combination chart. And measure values contain all the measures, and this can only be used with a combination of measure names and measure values. Now I will show you how to create multiple line or combinational chart by using these two things. So let's go. Yeah, so I will take sample superstore data. Okay, and I will show you measure names. Okay, so these many measures are there in this data. These many measures are there. So I just want to see few measures. So if I put measure names, so in the filter and select this, see, these are all measures: profit ratio, sales forecast, days to ship actual. All these are measures. So you can just directly select whichever measure you want to show, like sales, profit, and then select OK. So you will be able to see only those two. And now I will show you the combinational charts. So I'll just date, okay, and month, and I'll select a line chart. Okay, like this. So the black one is sales and the pink one is profit. So likewise, I can show both the measures at a time, or any of the one I can make it as a bar. Yeah. So one of them I can make it as a bar, and the other one I can make it as a line chart. So this is the advantage of measure names and measure values. So see, I had Tableau automatically kept that measure names in the color. So each and every measure represents in a different color. Profit is in this color and sales is in that color.
Yeah.
And there are other fields as well, longitude and latitude, and the number of records. So this is also an auto-generated field in Tableau, which will get generated if we have any geographical information in the data. Let's say country, state, city, district, or pin codes. So all these things will come under geographical information. And for every geographical information, Tableau will automatically generate longitude and latitude for that. So these fields will help locate the state, country, city, postal code in the maps. So these are automatically generated, and if needed, depending on the requirement, we might need to. So manually, sometimes we create a longitude and latitude fields to create some flow map charts. Like if you want to connect some state to other state, let's say you want to connect Delhi to Mumbai, Mumbai to Karnataka, like that. So we might need to create a few longitude and latitude in the data level, and then we can connect those points. And number of records, it will give us the information about the total number of records in the table. Sometimes this field can also be used in the calculation. So now let's see about this longitude and latitude. Let's go to our data. Latitude and longitude. So it is not showing anything, but we need to keep the country in the detail. Yeah, it is showing normal geolocation. So now let's select map. So select this map. Okay. Or you can directly put automatic here. Okay. So with this longitude and latitude, we can see the exact location of the countries. Okay. So live connection and extract connection. So now let's talk about live connection. So live connection is represented by a single cylinder. So by default, whenever you connect to any database, so it will be in live connection. So now let's see. So now I have connected to this Excel file. So by default, it is in live connection, live mode. And you can see that information here as well. So connection is live. And here also you can click on extract. So while going into the sheet, it will extract the data and it will show it. Okay. So live connection is like connecting to the data source directly. So whenever some change happens in the backend, so it will automatically reflect in the Tableau. So it is better to keep dashboards in live connection in case you have data which is updating very frequently. So in case of data, let's say stocks, so you want that data to be updated very frequently. In seconds, it has to be updated. So in such cases, we go for a live connection. So by default, whenever we connect to any data source, it will be in live connection, and it is denoted by single cylinder as shown in the title. And yeah, so that is about live connection.
Yeah.
Extract connection is like connecting to the snapshot of the data. So at that point of time, whatever is the number of records which are available. So let's say you have 100 records in the data. So it will take those 100 records into consideration, and it will save it in the dashboard level. And later, in later point of time, the data is getting updated with 120 or 150 records. Tableau will not take those records until unless we do a manual refresh or a scheduled refresh. And extract has to be done manually, or scheduling can also be done. So now let's see how to extract the data. So now I have this live connection. So now I'll right click on that particular data source and click on extract data. So we will have lot many options. So while extracting the data, also we can put some filters. So we can select the country if you want to pull out only one particular country or one particular region or anything. So we can apply those filters here. That's a region also. So I just want only a packed region while extracting the data. Instead of getting all the three regions, I can filter it out here itself. That is one option. I need all the regions. Yeah. And aggregate the data to visible dimensions. So let's say you have country region. So these are the two dimensions. So it will aggregate by default. It will aggregate to the country and region level. So whenever you refresh, it will refresh. Let's say you have 100 records. It will refresh all the 100 records. And next time when you have 110 records, next time when you do a extract refresh, if you have 110 records, it will upload all the 110 records again, like from starting to. It will remove the existing records and it will extract the 110 records. But when you do an incremental refresh, we can apply to identify new rows. Let's say you have 100 records in the database. If you are pulling out 100 records, and the next time when you are pulling out extra 10 records, so it will not delete the existing records, but it will find out whatever are the new extra 10 records, and then only it will fetch the data. Okay, we can specify that particular logic as well. Tab table to refresh sheet 2. So based on the, we should give some column name which identifies the new rows, and then it will take the data. So now let's just put all rows.
Okay.
Because we are pulling it for the first time, we need to pull it all the rows. But when while refreshing for the next time, you need to click on the incremental refresh, and mostly in the data you should have date field. Based on the date field, or you should have some IDs. So based on the IDs or the name, date field, you can do an incremental refresh. So now I'm doing extract. So it got extracted. So that extraction will be shown in a double cylinder. And that now the data is attached to this Tableau file. And also, so it will not take any updates from the file from now on, until unless you refresh or
Okay.
until unless you refresh or do any schedule refresh, it will not update the data. So it is generated with a double cylinder like this. So extract can be done by right clicking on the data source. A new window gets open to apply the incremental load or top rows load. So that is the process to extract the data. And once the extract is done, but you want to go back and keep the data source in a live connection. So we need to uncheck this use extract. So now, then it will become live again. So you can do extract like this. And when you want to go back to live connection again, you need to hit this one. So this is the procedure to create a live connection or an extract connection. And as we discussed in our previous session, so depending on the requirement, we keep the data and extract our live connection. Let's say In the case of data, if we are getting by monthly or weekly, so in that case, then there is no point of keeping the dashboard in a live connection. Instead, we can keep the dashboard in extract mode and put the schedule refreshes for weekly or monthly. Okay. Now let's talk about the extensions and how to save the workbook. Um, so let's see, and I think yesterday we discussed about this particular topic.
Yeah, yesterday
Now,
we discussed about TWX and TBX, right? Yeah.
yeah, we discussed this. So these are the two options which are available: TWB and TWBX. Okay. So TWBX stands for Tableau Workbook Extract, which is a packaged workbook. So, Tableau Workbook Extract contains all this. It contains data, images, custom color palettes, and also visualization. Okay. So, sorry.
Basically, contains everything what we did, right? Data, visualization, and everything. TWBX. Whereas the
Yes.
TWB doesn't have the data.
Yeah. Yeah.
Yeah.
So TWB won't have this data, images, custom color palettes. It will only have this visualization.
Okay.
So when you connect to the data, it will have some images and custom color palette. Let's say when I say custom color palette, see, I have this color for profit and sales, right? So when I save this as a TWBX and I send this to you, and you will see these two colors, same colors. But if I'm saving this as TWB and in your PC you are connecting to the data, you might not be able to see the same colors. Why? Because these are the custom colors which I have selected. In your PC, you will be having this custom colors according to your PC.
Okay.
Okay, so with that, we completed this session 3. So do you
Yeah.
have any questions in session 3 before we go into session 4?
No, so far good. Yeah. Let's continue with session 4.
Uh, so in this session, so this is about organizing the data pane, and there are some default settings. So yesterday I just showed you how to put the default settings for aggregation. So today we are going to see more options. Not only aggregation, we can put some default setting for shapes, for colors, and everything. And about combined fields also we are going to see. These are the topics that we are going to cover.
Okay.
So we can create hierarchies and basic usage of calculation fields. So most of the time in Tableau, we just use the tool. Let's say it's a drag and drop tool. So we just create charts by dragging and dropping the fields into the workspace. But there are some calculation fields that we write, like there are some calculations by using if else statements and by using case statements, we write some calculation fields. So today we are going to discuss about few of the calculation fields which are basic.
Okay. Yeah.
How to edit a calculation field and all, and about dimension and measure. And there are some blue fields and green fields in Tableau. And what are those green fields and blue fields in Tableau? And we have some 40 to 50 functions in Tableau. So if we learn about those 40 to 50 functions, then it's easy to write the calculations and everything. So with that, all the functions, we will be able to create or visualize anything in Tableau. So when we connect to data source, Tableau automatically separates date fields into hierarchies. So you can easily break down the visualization. You can also create your own custom hierarchies. Okay. So Tableau automatically, few of the things Tableau will automatically understand and it will create the hierarchies. So in case of date, In case of date, so date you won't have any. Let's say how we are entering the date. Okay, so we are entering the date like this,
Okay.
and let's show you some data. Okay, so we have the date like this. Okay, and Tableau, what it does is it automatically creates one kind of hierarchy. Let's say 2018, there are 3 records here, and there is one more 2018 here. Likewise, in the entire data, like if you want to see the 2018 data, and in 2018 you want to see January data. So if you want to do that, you need to have some kind of hierarchy. So Tableau will automatically do that hierarchy for us. So when we have date in the date format, Tableau automatically does it for us.
Okay.
Let's say order date. So if you see, if we have 2016, 2017, 2018, it automatically segregated. So if you are seeing sales for this particular years, so it automatically segregated. So what it does is, let's say order date. So what is it doing? Years, let's say 2018. If you want to calculate the 2018 sales, what is it doing? It will select those sales data for 2018. It will select that 2018 data, and it is giving us the sum of sales. So likewise, we also have so many options. Okay. So if you see, we have year over year and year also year. So I will tell you what is the difference between this quarter and this quarter, and this month and this month. So basically, this year and this year is both are same, but this is in continuous mode. So continuous mode, we can create charts, let's say line chart or something like this. But in discrete mode also, we will have this chart. But you can see, but it is not in a discrete mode. So now let's talk about quarter. Okay. So basically, we have 4 years of data. If you're seeing order date, okay, we have 4 years of data. But when I make this as a quarter, it is showing you Q1. So what is it doing is, it is having 2016, 2017, 2018, 2019, all these 4 Q1 sum of sales is in this particular field. Likewise for all the Q2, Q3, Q4. Okay, so this is what is this quarter. But when you go for this quarter, here you see quarter and year. In this case, you have only quarter. So here you will have quarter and year. So each and every quarter you will be able to see the value. Let's make it discrete to see the correct values. Okay. So 2016 Q1, 2016 Q2, 2016 Q3. So earlier what happened when you select first quarter? So it is giving you Q1 value 2017, 2018 and 2019 Q1. All the sum 434067. So let's make this quarter 434067. So the usage of this, I mean the difference between this quarter and this quarter is, this is a combination of year and quarter, and this is only normal quarter. And now same goes for month as well. So this is only month, and this is month and year. So let's click on January of all the 4 years, February of all the 4 years. And when you select month and year, it will show you all the months and years. Make it discrete to see the values. Yeah.
Okay.
It will show you all the month and year. Okay. So this is about okay. Let's see about day also. So day also 1, 2, 3, 4 till 31 you will have. So one of all the months, one of all the years will be there in this particular one. But in
Okay.
case of this one, each and every day, month, and year, everything you will have in a separate thing. Let's make it discrete. Yeah. So month, day, and year. So this is the advantage of date field. So when you have date field in a date format, then you can use this functionality. Let's say you can make year, month, date, weeks, everything you can segregate. But if you are not having date in a date format, then it's very difficult for you to segregate all the years in one place, all the months in one place. It's very difficult to maintain. So whenever you are trying to get the information, so everything has to be in a popular perfect format. So now we are talking about hierarchies. Now I'll just show you what is hierarchies. So you have this symbol which is expand. So when you click on this here, so from here you go to quarters, right? From quarters you go to months,
Month.
you go to
Days.
days. Yeah. Okay, this is the last hierarchical level or lower granularity where you can go. Okay, let's just swap. Yeah. And now you want to go back, or you can. Okay, so in the so this is at the developer level. So while publishing or while showcasing it to the user will not be able to see this row shelf or column shelf or this marks card everything. He will be able to see only this particular space. So we can give this option to the user as well. So if he wants to expand or collapse, he can do it from here actually, like this. You don't want to show days. You don't want to show months. You don't want to show quarters like this. Or you want to expand. Here also you can expand. So this is what is hierarchy. In the days, days together called as months, months together called as quarters, quarters together called as years.
Here.
This is the by default which comes from Tableau itself. Okay, and so when you have region, state, country like this, so Tableau automatically understands cities together called as states, states together called as countries, countries together called as regions. So Tableau automatically understands that and it will create a hierarchy. So let's see.
What is cities called? You said country is called region, right? What is city called?
I don't mean that. Okay, so if you see countries together, I mean together in the sense, I mean APAC region has 3 countries.
Okay. Yeah.
States, I mean
Asia Pacific, Africa, China.
in India we have different states. All the states together, let's say we have 29 states. All these
Mhm.
29 states together called as India.
Uh-huh.
Like states together called as countries, countries together called as uh, regions likewise. So this is the hierarchy, right? Let's say
Okay.
insert state. State we have Karnataka, Telangana. Under India, we will have all this, right? So this is a hierarchy. First India, then states. Then in the state, what are the cities? In the cities, what are the pin codes? This is the hierarchy. So what I'm saying is, so Tableau will automatically identify countries. Under the countries, we will have states. Under the states, we will have cities. So this regions and locations, Tableau will automatically identify. So that's how it creates. See, if you see the location. So this is in a hierarchical order. So let's say if I put this region and if I expand under central, okay. So there is only United States data in this superstore. So in United States, what are the states? So these many states are there. And in each and every state, what are the cities? And in each and every city, what are the pin codes? Like this. So this is the hierarchy which Tableau will automatically create. I'll tell you one more. Let's say in any organization, we will have manager. Under manager, we will have 10 employees. Okay. Let's say 10 tech leads, if you say tech leads. And under each and every tech lead, we will have 2 employees. So that is the manual hierarchy, and Tableau won't understand that. For that reason, what we do, we create that. Let's say okay, so let's say here we see country and region, right?
Yeah.
Okay. So Tableau mostly identifies only the country names. So APAC, EMEA, these are the normal abbreviations that we keep. So Tableau doesn't understand this particular abbreviations. So that is the reason we don't create any hierarchy for that. So now what I will do is I'll just select region and I'll go to option hierarchy. So let's create a hierarchy. I'll drag this country and put underneath the region. So now you see this expansion. So now if we expand this, we will get countries under the region, and you can collapse like this. So earlier you didn't have this option. So I'm just doing Control Z. So before doing hierarchy, when I have this region, see, you don't have that expand collapse symbol. So you can't expand. You need to manually keep this country over here. And you don't get this option here. So it is to give your user option to select the hierarchy. So you create hierarchy, like location hierarchy, and put this country under the region. Okay, and put the region over here. And you can select the expansion or collapse. So under the region, you will have countries. Under the countries, you will have cities, or you will have states. Under the states, you will have cities. So this way, sometimes you need to create manual hierarchy. Is it clear? So when we connect to a new data source, Tableau assigns each field in the data source in the dimension area or in the measures area. So when we connect to any database or anything, So Tableau automatically segregates that dimension and measures. And so when you put any dimension in the field, so that becomes your dimension will be in blue color. So every time when you put any dimension, that will be all that will be in blue color, and we call this as a blue pill. We call that as a blue pill. So dimension, most of the dimensions will be in blue color. So with the color also we can identify it is a dimension. Most of the measures will be in green color. So this is not related to like user level. So user won't see this blue color or red color or anything. So it is just for our understanding, to understand what is dimension, to understand what is measure. So now let's see what happens when I put sales. So by default, when you put something uh, in the row shelf or column shelf, if it is a measure, so that will be in green color. And there are situations where dimensions can be in green color. Only in case of date dimension. Only in case of date dimension, we can keep that in a blue or green color. So now let's see what happens when we keep a date dimension. Okay, so now you see it is also a dimension. So whenever you put some dimension in row shelf or column shelf, it will be in blue color. But this dimension we can also make it as a green color. Why? Because there is two things called which is discrete and continuous. So continuous is something which shows like a flow. Let's click on this. Yeah. So now it is in green color. So to create or to make some charts or line charts or anything, so you use this continuous mode. So salary. Let's put the day over here. Okay. Okay. So with this, what happens is it will show like a flow. So that is the reason we make that as a continuous. So discrete, it will what it does is it will show discrete values. Like it will not show like a individual value. So discrete is something it will show only particular value by value. But continuous, it might miss some values in between. So let me just show you in another chart. Uh, let's say take sales and date or a date. So it is showing me this output where you can see all the years. Why? Because we have only 4 years there. And if I'm converting this to a month, let's convert here. Okay. So this is now in continuous mode. But what I'm showing here, I'm showing month and year, but it is not showing me all the months, all the years over here. It is just showing me 2016 and 2017. But I can understand the flow of the line chart, whether it is trending up or trending down. But what if you want to see each and every value? So if you make it discrete, then you can see each and every month and year. But if you can't see the flow at a time, you are getting this scroll bar. But you want to see only the flow, then you go for continuous mode. So with that, what you can see is you can see the flow, but not all the months and years. So that is the main use of continuous and discrete mode. So with continuous mode, we can convert a dimension from blue to green. So this is one thing, and measures can also be in blue color. In which case, now let's see in what case the measure can be in blue color. So now let's put some region and some sales. Okay, so this is in continuous mode. In continuous mode, what happens is it will show some flow. So now it is showing axis. So with continuous mode, we will get axis, but it is hard to understand the data. For APAC, you have one bar. For EMEA, you have one bar. So instead of that, let's say in this case, I want to show a tabular chart. So in that case, what I will do, I will make it as a discrete. If I make this as a discrete, then I can see each and every value of that particular sales. Hello, Venkat. Is it clear or do you have any doubts?
No, sir. It's good.
Okay. It's other way around. When in case of measures with discrete mode, we can convert a measure into measure from green to blue. So this is technical information. This is not associated with a user. So it is just for our information, for knowledge purpose. So it just knows like what is this blue color and what is this green color. To understand about the difference of that, I'm telling you this information. Now let's see in the PPT. So dimension contains qualitative values. You can use dimensions to categorize, segment, and reveal the details in your data. And dimensions affect the level of details in the view. So whenever you keep any dimension in the workspace that I have shown, so it will impact the level of detail of the view. And measure contains numerical and quantitative values. So measures can be aggregated. So this is the definitions of dimensions and measures. Okay. So blue versus green fields. So most of the dimensions will be in blue color and most of the measures will be in green color, and there will be blue measures and there will be green dimensions. So that we have discussed. Okay. So these are the combination fields which are there in Tableau. Like this is the difference between continuous and discrete is. So continuous will show us the flow of the chart, and discrete it will show you the individual values, and it will also show the flow, but comparable to the continuous, it will the impact of the discrete is to show the individual values. Okay. Now let's start discussing about few of the functions in Tableau. So we have number functions and we have string functions. So these are the types of functions which are available.
Yeah, data types.
No, these are not related to database. These are Tableau functions.
Okay.
Okay. So these are the member functions. So these are the functions that we use while we write our calculations, string functions and all this.
Oh, okay. Okay.
Okay. So why we use number functions? So number functions allows us to perform computations on the data values in our fields. So today we will discuss more about this number functions also. And number function can only be used to convert the numerical values. So let's start this number functions. Okay. So we'll go one by one. So let's go to Swam to Superstore data and let's put sales and we'll make it as table and I'll put some product of product. Let me just say some table. Let's take segment. So segment wise, I'm showing this sales. Okay. And now I'm going to create sales. So there are many ways that we can create a character field. So you can click on this drop down and click on create character field, or you can go to analysis and there also you can see create character field option. And click on this number function. And the first function is ABS. ABS. For this, let's take profit as well. Okay. So in profit, we also have negative values also. These are the profits and these are the, so formatting is like this. Let's change this format. Custom. Okay. So you could see the negative values also. So what I'm trying to do with this profit is, I'll write an absolute. So absolute is a function which will not consider the negative sign or the positive sign. It will always show positive value. So absolute. I'm applying this. Absolute. I'll put it over here. Okay. So whenever we are writing some calculation, you need to put sum of profit. So sum is mandatory. Say apply and put this absolute over here. Okay. So now you see 49,993. So everything will be same. And in case of negative, what is happening is it is not showing you the negative sign. It is always showing you the positive sign. So these are the some kind of requirements that you get. Let's say absolute and subcategory. Okay. And I'll write one calculation. First sum of profit less than 0. Then This is some simple calculation. I'm just writing down. Okay. So this is my color condition. What I'm doing is whenever my profit is less than 0, I'm just saying it is to be red. If I'm getting negative profit, that means I'm in loss. So I'll put that color condition. See, like this. So what is happening? So I want to show my graph into the upwards only. Like I don't want to show in the negative side of it, but I want to show in the upward direction only. But I will show it in a different way. See, I'm in red color. Why is it in red color? Because I'm having negative profit. So instead of absolute value, what happens when you keep normal profit? So it will be in the opposite direction. Why? Because it is negative. But in some cases, user will ask for don't show it in the negative side, show it in the positive side only, but represent with a different color. So in such cases, we go for this absolute calculation. So that is one kind of requirement that users ask for. So that is about absolute. And okay, now let's create another calculation. And ACOS. So these are the some calculations or trigonometrical calculations. So if you want to use, we can, let's say, we can use this calculation, but these are not useful much because it will just show us the value of this 3.14. The ACOS of -1 is 3.14. What is it doing is it is summarizing the 3.14 value for all these accessories. So if you want to see that 3.14 value, you need to do an average format, make it custom. Yeah. So that is just trigonometrical calculation. Whenever you want to use that particular thing, then we go for this trigonometrics. The same goes for assign. So let's put assign, apply. So it shows us 1.57. Minus it is showing because I had kept minus over there. And same goes for A10. A10 180. And 180 1.57. So it is doing a round figure and it is showing 8 and 2 2,1. So we can see the description over here on how to write or how to use the functions. So we can they will provide the description as well, and it is giving you 1.11, and it is round figuring the value. And now let's discuss about ceiling. Okay, ceiling is also, let's say, sometimes when we are doing round of function, what we do is we take the higher number. So ceiling is 3.14. So according to mathematics, so 3.14, if you are rounding it off to 0 decimals, that will become 3. But ceiling is one thing, it will take the greatest value instead of taking the lowest value. So now let's see. Now we have all these profit values. So I'm writing a ceiling function of sum of profit. And say apply. Ceiling. And say apply. Okay. If you see, we have 49,993.13. So according to mathematics, it is 49,993 if you are rounding it off. But as it is taking the highest value, it will go to the 94. So same goes for all the lowest ones. 58.36, so it will show you 59. So ceiling is the function which gives you the highest value. It rounds a number nearest integer of equal or greater value. So that is the usage of ceiling. Number function and cos, cot are same. So we don't use these calculations much, but if required, we use these calculations. And decrease also same. Div. Okay. So div is something. Let me create a new one. Div 11 comma 2. Apply. It just gives the division of 11 by 2, which is 5.5. To see that division, you need to make this as an average. Format, custom. So it gives us the integer part actually. So 5.5, whenever you are converting it, it will just show us the integer part. Okay. Now let's go to the other function. Exponential. So if you want to show the e to the power of 5 or e to the power of 6, say apply. That is showing you the e to the power of 6. Okay, then we'll continue tomorrow.